Hi, we're still on the 4.4 notes which pertain to the fundamental theorem of calculus, and we're looking at how you go through and take the antiderivative of an absolute value. And I'm going to graph this, and the way I'm going to graph this is I'm going to set 2x minus 1 equal to 0 because that's where the x-intercept is going to be, and I'm going to get x is equal to 1/2, and I'm integrating from 0 to 2, so I'm going to break this apart. Here's 2, here's 1, and here's 1/2. And if I put, see, and I'll have 1, 2, and 3 is probably right here. And so I have 2, 3. And here is 1/2, and if I put 1, I get 1 because 2 times 1 is 2, minus 1 is 1. So I'm drawing this line here. If I put 0 in there, I get a -1, but the absolute value of that is 1. Alright, so I could figure this one out pretty easily geometrically, and I'm going to do that. And if I take a look here, the area of this is a triangle, and its area is 1/2. The base is 1/2, and the height is 1, and I get an area of that of 1/4. And over here, it is also a triangle, so I have 1/2. The base is 1 and 1/2, which is 3/2. And the height goes all the way up to 3, so that's 3 over 1, and I get 9/4. And if I add 1/4 plus 9/4, I get 10/4. And so I should get an area of 5/2. Alright, so when I'm integrating this from 0 to 2 of the absolute value of 2x minus 1 dx, I'm going to break it up into two integrals. One is going to go from 0 to 1/2, and the other one is going to go from 1/2 to 2. Alright, so let's take a look at what I do here. Well, if I didn't have this absolute value symbol, what would happen was this line would continue in this direction and go below the x-axis and continue on. And what happens because of the absolute value, those negative y values are reflected over the x-axis and become positive. So what I'm going to do is I'm going to take and multiply. I'm going to multiply 2x minus 1 by a -1, because from the interval 0 to 1/2, those y values are negative. I'm going to make them positive by multiplying by a -1. From the interval 1/2 to 2, they're already positive, so I'm going to leave them as 2x minus 1 dx. And so, and I'll do another example, but every time you have that absolute value, you have to find those x-intercept points and take a look whether those values are positive or negative and make a determination. And I'll show you how to do that on the next example. So if I distribute that negative sign from 0 to 1/2, I'm going to have a -2x plus 1 dx plus from 1/2 to 2 of 2x minus 1 dx. And if I take that, I get a negative x squared plus x evaluated from 0 to 1/2 plus x squared minus x evaluated from 1/2 to 2. Alright, so now I'm going to plug these in. Now I can kind of see ahead that when I plug 0 in, I'm going to get 0. I'll be subtracting 0. So all I'm going to do is put 1/2 into here. And I'm going to add to that when I put the 2 and the 1/2 over in this particular spot. So there I'm putting in b, and I'm subtracting a on this portion right here. Okay, so this portion is this integral, this portion is this integral, with the 0 being eliminated because it's not helpful. So right here I have a negative 1/4 plus 1/2. And like I said, I'd be subtracting 0, so it's going to end up being, I'll bring it over here, 1/4 plus, now I'm going to integrate this, 2 squared is 4 minus 2 is 2, minus, now right here I'm going to have 1/4 minus 1/2, that's going to give me a negative 1/4. So that's going to be 2 1/4. So I'm going to add 2 1/4 to this. And I get a total area of 2 2/4, which is 2 1/2, which geometrically I should have got as the same answer.